I'm sure you've felt a static shock and seen bolts of lightning in a thunderstorm. You may have even stuck a balloon to a wall after rubbing it against your hair. These are all examples of electric force and electric charge, which I'll be teaching you about in this video. Electric charge is a property of matter that causes it to experience a force when placed in an electromagnetic field. For the purposes of this video, we will define an electromagnetic field as the area where an electric charge is able to exert a force on other charges nearby. Charges can be positive or negative. The most common positively charged particle is the proton, which has a charge of E. E is the elementary unit of charge, and the smaller of the two we'll cover in this video. The most common negatively charged particle is the electron, which has a charge of negative E. One phenomenon with electric charge that you've probably encountered is the triboelectric effect. This is when two objects rub together, causing one to pull electrons from the other. This creates one charge on the first object and the opposite charge on the second. Since opposites attract, they will be drawn towards one another. An example of this is when you rub a balloon against your hair, then your hair stands up in order to remain in contact with the balloon. The balloon removes some of the electrons from your hair, making it have a negative charge, and leaving your hair with a positive charge. Since opposites attract, your hair will be accelerated towards the balloon whenever it is nearby. The other, larger unit of charge is the Coulomb, which is represented by the letter C. It is roughly equivalent to 6.24 quintillion elementary units of charge. To help you visualize how much charge this is, 1 Coulomb is comparable to 1 million static shocks, or a tenth of a small lightning strike. The magnitude of the force exerted by an electric charge can be represented using Coulomb's law. This equation takes the charges of two objects at radius r, takes the value of the product of the charges, then multiplies it by the electrostatic constant, which we'll cover in a moment, before dividing it by the radius squared. If you haven't already noticed, this is very similar to the formula for the force of gravity. The electrostatic constant is equal to this number, which can be approximated to about 9 billion, and the units are Newton meters squared per Coulomb squared. The reason this unit is so complex is to allow the units used in the equation to cancel out, leaving just a force in newtons. It is fairly simple to determine the direction of the force. If the charges are the same, then the force on the objects is away from one another. If they're different, the forces are towards one another. Hopefully you found this video useful.